Hello friends, I am Piyush Goyal and I welcome you to Voxcel's YouTube channel. So this is our 16th video of this particular series of true, false and not given. So let's start. Measuring snowfall. So in this particular video we will look at this particular passage of measuring snowfall. So by the title of the passage it should be clear to you that this passage we should expect to read information about how we measure snowfall or how we measured snowfall in the past. Basically measuring snowfall, it could be like in present, how we are measuring snowfall right now, different methods we could read about this, or what to expect in the future regarding this field. Now keep in mind that we may or may not read something like that, but thinking like this will help us activate our vocabulary, channel our brain in that particular direction, so that we can, when we read this information, we do not get distracted or we do not get nervous. So after reading the title of the passage, we will go straight to the first question. Okay, we have to write true, false and not given. First question, NCAR accepts the need for more precise methods of measuring snowfall. So this is basically, let me highlight it. This is basically name of an organization. So NCAR accepts the need. So there is a need for more precise method of measuring snowfall. So if this particular organization is willing to accept new method, is trying something new or trying a new method so they can be more precise, we will say true. But if this it says this is this organization is happy with the current methods, they are like more than sufficient, current methods are more than sufficient, we will say false, because there is no need for more precise methods if you are satisfied. But if there is no information regarding this, we will say not given. We will start reading. Despite the many high-tech instruments now available to scientists who study the weather, one measurement remains relatively difficult to make, and that's calculating how much snow actually falls in any particular place during a snowstorm. This explains why the National Center for Atmospheric Research. So this is our locator word, or you can say keyword. Let me change the color, please. Wait a second. Okay, so just one second. So this is why National Center for Atmospheric Research (NCAR) in the USA is experimenting new ways of achieving a greater level of accuracy in snowfall figures. So this organization is trying to trying to invent new ways so that a greater level of accuracy can be achieved. So if they are trying new ways for greater level of accuracy or for higher level of accuracy, so they accept there is need for more precise methods. So what we will do, we will say the answer to this is, let me do one thing, let me write here if it is possible. Okay, let me add text. One second, let me add text here. So our answer to this should be true. Hope it is clear. Next question. Researchers have found ultrasonic sensors more reliable than laser sensors. So if researchers think that ultrasonic sensors are more reliable than laser sensors, we will say the answer to this question is true. But if the opposite is true, like laser sensor are more reliable than ultrasonic sensor, or if ultrasonic sensors are equally reliable as reliable as laser sensor or equally reliable as laser sensors, we will again say false. But if there is no comparison between these two sensors, like which is more reliable, which is less reliable, we will say not given. Okay, now we're gonna read it further. As their representative Ethan Gutman points out, you'd think it was just a matter of going out and sticking a ruler in the snow and measuring how much is on the ground. The problem is if you move the ruler over just a few centimeters, you may get a different reading. There is still no comparison or mention about ultrasonic or laser. So we'll read a bit faster now. In fact, taking measurements is complicated by a number of factors. For example, the first snowflake may melt as soon as they hit warm surfaces, while others are whisked away by the wind, leaving some ground bare and other places buried under deep snow drifts. Gutman's colleagues have been testing a number of new snow measuring devices, including ultrasonic snow depth sensors, which send out a pulse of noise and measure how long it takes to bounce back from the surface below the snow, and laser sensors, which work on the same basic principle but use light instead of sound. Another device for measuring snowfall is a type of open container with motor vehicle antifreeze inside it. This is some other instrument. So, though there is mention of ultrasonic depth sensor and laser sensor, but there is no direct comparison between the two. They have just written how ultrasonic sensor works and how laser sensor work, but there is no comparison between the two. So, because of that, we will say the answer to this should be not given. Hope it is clear. Next question. The device that uses motor vehicle antifreeze. So we have just read about this. Let me underline, highlight this. The device that uses motor vehicle antifreeze measures the amount of snow both before and after it melts. So when the answer will be true, when this particular device, instrument, equipment, whatever it is written over there, measures the amount of snow both before and after it melts. So if it melts the weight of snow before and after it melts, we will say true. But if it measures only before or only after it melts, we will say false, like either of these two. And if we don't know when it measures the weight, like before or after, when it is not given, we will say not given. So this is, here we have read it. uh, Okay. Another device for measuring snowfall is a type of open container with motor vehicle antifreeze inside it. The antifreeze melts the snow as it falls and sensors measure the weight of resulting liquid. So what it does is it melts the snow and the weight is measured of the resulting liquid, not before. So it doesn't measure the weight before melting, it just measure the weight of resulting liquid after melting it. So because of this, we will say the answer is, just one second, false. I hope it is clear. Moving forward, just okay, let me do this now. Next question. Using GPS technology, so we have to find this particular keyword, GPS technology would be more expensive than using alternative devices being tried out. So if GPS technology is more expensive than the alternative methods, we will say true. But if it is like cheaper than alternative methods or equal in price than alternative methods, we will say false. And if there is no comparison of prices given, we will say not given, obviously. So NCAI scientists have also experimented with global positioning satellites. So here is our keyword GPS. Okay, let me change the color just to measure snow depth. It may be possible for signals sent from these satellites to measure the distance to both the surface of the snow and to the ground beneath it. Not only would this method be more cost effective, okay, so this method is more cost effective than other methods, alternative method meaning to say other methods. So if it is cost effective, obviously it cannot be expensive, and for that particular reason we will say the answer is false. I hope it is clear. Next question. GPS technology could allow snowfall to be measured across a wider range of landscapes. So if with the help of GPS technology, if with the help of GPS technology we can measure across a wider range of landscapes, so we will say true. So in the question, or sorry, in the paragraph, instead of a wider range of landscape, they may give two, three, four geographical locations instead of writing a wider range of landscapes, okay, or they can say different synonyms for this. But if it doesn't allow to measure across a range of landscapes, we will say false. And if we don't know where we can use this technology or what are the limitations or benefits of this technology in terms of landscapes, we'll say not given. But this might also be particularly useful for measuring snow in remote locations such as inaccessible upland areas and the highest mountain peaks and ranges. Yes, it is beneficial because we can measure snow in remote areas as well. Just let me change the color. So we can measure snow in remote areas as well, like inaccessible upland areas or mountain peaks and ranges. So yes, we can measure snowfall at different places, and because of that we will say the answer to this is true. Clear? Moving forward to the last question. The use of a snowboard is particularly effective in areas with high winds. So if snowboard is effective in areas with high winds, we will say answer is true. But if it is not effective, it performs rather poorly in areas with high winds, we will say false. And if the effectiveness of snowboard is not mentioned, like if it is effective or not effective, ineffective, we will say not given. Accurate measurement of snowfall in these areas is important as entire regions may depend on spring runoff of melted snow for their water supply. The scientists also learned that they could improve the results of both manual and high-tech methods of snow measurements by using something known as snowboard. So here is our locator word. Basically, this is just a flat piece of white painted wood on which snow can accumulate. Windshields placed around these can also add to the accuracy of measurement. So we can make our measurements more accurate by using windshields, but are they more effective, or are they effective in areas with high winds? So the high winds or areas with high winds, such things are not given, not mentioned here, so we don't know about that. So just simply we will say the answer to this should be not given. I hope it is clear how to solve true, false and not given. So if you still have doubt, you can watch our other videos or you can contact us. I'm gonna leave the link to our website in the description box, or you can see the comment box, and you can contact us from there. We will be happy to help you. I will see you in the next video. Till then, take care and goodbye.